10.5. Apply other angle relationships in circles. Essential question. How do you find the measure of an angle formed by two chords that intersect inside a circle? We're going to be talking about intersecting points in, on, and outside the circle. So let's take a look at what these actually look like. So here we go. What does this look like on the circle? So that would be a line here, and a line here, and intersecting here. So it kind of has a look of an inscribed angle. Inside the circle, we've got a circle here, a line here, and a line maybe doing something like this. Now, this could be a central angle, but it rarely is a central angle. This is just called an interior angle. And outside the circle, and we've had this, so it looks like a secant here and a secant here. So there's our intersecting point. So we have secants intersecting outside the circle, secants intersecting in the circle, and secants intersecting outside or on the circle. So let's go ahead here. If a tangent and a chord intersect at a point on the circle, then the measure of each angle formed is blank of its intercepted arc. So let's go ahead here and draw this. So if I have a tangent, point of tangency, and I have an angle formed, what is the relationship between this and this angle here? And in fact, it's very similar to what an inscribed angle is. It's half of its intercepted arc. So in this case, I could have the example of the following here. If this was 200 degrees here, then this angle from here to here is 100 degrees. So very much like an inscribed angle. So now let's see a couple of problems on this here. So exactly what we're asking, what is this angle here? We're going to say it's 1/2 of 210 degrees, which is 105 degrees. So this is 105 degrees. Over here, they're asking what is the measure of this arc here if this angle is 80? Well, that would be just going the opposite way here. This is half of what it is. So I'm going to go ahead and take 2 times 80 equals 160. Or we could say that the measure of arc xy is equal to 1/2, actually, never mind. We'll just kind of leave it at that. Theorem 10.12. Angles inside a circle theorem. If two chords intersect inside a circle, then the measure of each angle is, and we're going to change this, is the average of the measures of the arcs intercepted by the angle. And now let's remember that the average is 1/2 of the sum of that. So let's keep that in mind here. So perfect example here. They're asking about this angle here. Okay. So we're going to say the measure of angle 1 is equal to the average, so the sum, and times 1/2 or divide by 2. So this gets the measure of angle 1 equals 256 divided by 2, which comes out to be 128 degrees. So this angle is 128, and this angle is 128 because of vertical angles. Now continuing here, we have a little bit of a difference here, is that if a tangent and a secant intersect outside the circle, or two tangents intersect outside a circle, So again, what they're saying here is we have these three scenarios. If I have this, so if I have a tangent and a secant intersecting here, this situation, two tangents intersecting, that'd be like this and this. Or if I had two secants intersecting, so I got a secant here and a secant here. In each case, we have an angle, we have a small arc, and we have a big arc. We have an angle, we have a small arc, and we have a bigger arc. We have an angle, and we have a small arc, and we have a bigger arc. So all three of these have the same formula here. So the measure of each angle, so our angle outside is half the difference of the measures of the intercepted arc. So it's going to be the large arc measure minus the small arc measure. So just keep that in mind. We can't have negative arc measures here. So we got a few problems here to take a look at now. So again, I'm going to just keep this here. So this is a tangent. Here's a secant. I've got my small arc, got my big arc, and I've got my angle. So in this case, the measure of angle 1 is going to equal 1/2 the large minus, well, what the heck is this small one here? So we can find this by 360 minus 174 minus 119. So that arc there comes out to be 67 degrees. So I've got 67 degrees, and that will equal 26 degrees after we subtract and take half. Over here, looks like we have a secant and a secant. So again, the measure of angle 1 equals 1/2 of the large intercepted arc minus the small intercepted arc. That subtotal comes out to be 74. Half of 74 is 37 degrees. Continuing, this is a tangent. So first of all, to find this, it's going to be 360 minus 138. So that gives me 222 degrees. And now again, the measure of my angle equals 1/2 the large minus the small intercepted arcs. And here, we get a total of 84. Divided by 2, we get 42 degrees. Continuing here, again, looks like a tangent and a secant. Now here they tell us the measure of the angle, 1/2 the large arc minus the small arc. Now with this, we have to be a little careful on solving some options here. I like to go ahead and multiply both sides by 2, and that will do the following. We'll get 48 here. This will cancel that, leaving 118 minus x. Subtract the 118 over, and I get negative 70 equals negative x. So x, in fact, will be 70 degrees for that smaller arc. So just be careful with the algebra as you go here. We've got a couple of pretty heavy problems here for E and F. But again, it looks like we have a tangent and we have a secant. So the angle measure equals 1/2 the large arc measure minus the small arc measure. And here we just have to be careful. Because of the fact I've got to subtract a binomial, I've got to switch, and switch. And now I get 54 equals 1/2. Well, 13 minus 5x is 8x. Negative 6 minus 14 more is negative 20. Now I could multiply both sides by 1/2, but here I can just go ahead and run this half through, and I get 4x minus 10. So as I wrap this up, I'm going to get 64 with an add 10 step, and I'm going to get 16 after my divide step. So that's a 16. This last one here, first of all, if we go ahead, and this is an inscribed angle of the bigger circle. So that means this angle here is going to be 1/2 of 96, which equals 48. So now we are looking at this secant, secant, and we're looking at this circle. And I know the angle is 48, 1/2 the big arc, which is x, minus the smaller intercepted arc. Now this would be a great one to, again, multiply both sides by 2 to clean up that 1/2. So I get 96 equals, this cancels that, so I get x minus 32. Add the 32 over, next has to be 128. So a variety of problems, but most of them had a relationship of 1/2 the sum or 1/2 the difference.